This is a two-sample t-test for the mean difference between two samples, and we're going to do it using Excel. A magazine claims that the mean amount spent by a customer at Burger Stop is at least $1 greater than the mean spent by a customer at Fry World. The results of samples of customer transactions for the two fast food restaurants are shown below. At alpha of 0.05, can you support the magazine's claim? We are to assume the population variances are equal, the samples are random independent, and the populations are normally distributed. All standard assumptions. We always start by stating the two hypotheses. In this case, the claim of the magazine was that the mean of the Burger Stop was at least $1 higher than that at Fry World. So at least implies the greater than or equal math operator, which is a form of equality, which means that the claim must be the null. The alternative is the complement of the null, which would be that the mean difference, mu1 minus mu2, is less than $1. Because the alternative contains the less than operator, this is a left tail test. Be watchful for that. Although there is a two-sample t-test in the data analytics package, as I've mentioned in another video, the way that it is structured is confusing and students often make mistakes. Inside your calculator folder in your assignment materials, there is this two-sample t-test. We're going to use it a little bit differently here because we're interested in the mean difference. And it's very important that you put the sample information in the right order. In this case, 11.5 was the Burger Stop's mean amount spent. $10 was the Fry World. And these are the appropriate standard deviations and the samples. We need to put the mean difference in this case, it's $1. Our alpha level is 0.05. We need to remember to set this drop down either to equal or not equal. This problem is not equal. And the calculator will calculate the degrees of freedom, gives us the test statistic of 1.5, which is just the difference in the means. We calculate the standardized test statistic, which is 1.6787. And then we're given the information on the critical values and the p-values for the two-tail, left tail, and right tail tests. Remember to set this switch on whether or not the variances are equal or not equal. This problem, they're not equal. We're given our degrees of freedom, our test statistic of mu1 minus mu2, the mean difference is 1.5, and a standardized test statistic of 1.6. Then we're given the answers for the two-tail, left tail, and right tail tests. You need to remember which tail test. This one, because the alternative contained the less than operator, it's a left tail test. And we can see that the test statistic is not in the rejection region, which would be smaller than minus 1.8.5, and the p-value of 0.93 says we've got a lot of evidence supporting the claim, which was the null, that the mean difference was at least $1.